So this first part of the video is just discussing the workflow of the software, the various little components. Won't spend much time on this, so we can spend more time on the demonstration, but this is just to kind of give an overview of the process. So this is kind of a quick overview of the overall process here. We will talk about software, two different types of workflows, some of the basic logic that's involved within some of the nodes we'll be using, another example of the node logic, and then one more example of what these nodes actually look like in the code, and then we'll jump right into it. So let's go to the first frame. So we've talked about this before. I won't go into it too deeply, but the software is basically a mix of Autodesk products between Revit, Forma, and Dynamo, TestFit, and then there's future options for future software, for example, Arcol or Schema. Both do very similar functions to TestFit, but the main thing about all these is they have ability to tie into Autodesk and each of these other components. So it makes a comprehensive design solution. Now, this first workflow is basically just kind of an idea to iterate through the process, right? So example, you would start with Forma, develop a site plan, specify a parcel that you are going to define the site on. And whenever you know that parcel, you can start doing the things like code analysis, or you can run initial site analysis, things like a wind study, building density studies, pedestrian flow studies, noise studies, things along those lines. And that all feeds back into the parcel. From here, you can export out to Revit, at which point we come into the Dynamo portion of it. So what this will end up doing is exporting out various geometries, lines, for the most part on this first run, that we can start running the script. The script will be based off of rules that were developed from the case study and kind of knowledge that's pulled from the different siloing that happens in the groups in an architecture firm. It will also take into account a series of environmental rules, and we can discuss that. But as far as the rule-based design, this is things discussing the massing of the blocks themselves, circulation between the blocks, nodes for pedestrian access. And on the environmental side, this can be very simple, like sun direction and wind direction. All these things should be able to modify the blocks. So you run that, run the script. At this point, we'll have a series of blocks, and we can import this back into Forma. Once in Forma, we can run the analysis again. And the good thing about Forma is it's really adept at running environmental analysis. There's also other things that you can run on it. For example, you can calculate the FAR or parking counts, things like that. You can start getting some of that information out. After you've run your analysis on the new form, you can start discussing the findings and trying to understand what the best solution is, or if there needs to be modifications made to the solution. At which point, if there's modifications, and typically there will be, since we're going to iterate through this process, we'll go back up to the export out to Revit and then run the script and go back through this process again, putting in different inputs. As we work our way through the process, we'll eventually get to a point where the massing is good with where we're at. At this point, we want to go into TestFit, and TestFit will start implementing some of the additional interior layouts and options there. It also gives us analysis on pro forma, more detailed parking counts and things like that. So at this point, we'll run iterations on the different masses that we've developed to come up with kind of different layout options. We can start running more advanced parking analysis and the reviewing of any of the iterations that TestFit will end up putting out. At which point, if that's all good, we can continue on with the rest of the project. Or if there's more adjustments that need to be made, we circle back to Revit. It goes back out as the export, and then we run through the process again and keep refining it in this loop until we get to a solution that we're happy with. This is kind of the workflow of overview one. The next workflow is very similar. In this case, we're always starting with Forma. So we'll do a site creation, same thing, parcel selection, We'll specify the link to Revit. And then up here at Revit, we'll go back to the Dynamo script. In this case, we're doing something a little bit different. Inside Revit, there's a generative design command where essentially instead of in the original one, we were running one script at a time. This will run that singular script or a multitude of scripts multiple times, kicking back a variety of results, and it'll develop basically a report or a feedback that'll let us know, hey, listen, based off of the matrix or the parameters that you're interested in, these are the most efficient ones based off of your design. At that point, whenever we kind of go through that process and streamline through that, we can go back out to Revit, select the design we're going to go with, and then go back into Forma. Once we're in Forma, we can jump into the analysis of the masses. In this case, the same thing as before. There's the parking stuff, the environmental, the sun analysis, wind, sound. We can start looking at the carbon footprint. And we just start to keep going back through this process. But the difference here is this generative design option, which allows us to do more options, more design options up front than the previous overview of the workflow. From here, we'll select the design, and then the same thing goes back into TestFit. The problem here is we'll have to manually build all the masses that we've been developing in TestFit. There's no good way to link it up at the moment. But from there, we'll build it, and then we'll start doing the interior massing studies and layout studies with the masses we've developed earlier. And mostly this will function with the Multifamily Solver, not so much the grocery elements or the retail elements, or whatever elements you would have in there. TestFit also has a generative design option, similar to what Revit is going to do. So it'll generate multiple outputs based off of various inputs that you give it. Of course, once you go through that, you pick out the one that works best for you. And then from here, you can actually link the TestFit model, which is a more defined physical model, back into Revit. And of course, once we've gone through this process a numerous number of times and gotten to the most efficient design that we're going to go with, from here it goes from Revit, and then you start working into the model development. So talking about the nodes real quick. We'll just specify these real quick. So this is an example of kind of the node layout inside Dynamo. Now, from this is just a matter of packing logic and whatnot, and I'm not going to spend a lot of time talking about these. So basically, the commands are a series of cuboid and bounding box commands that have specifications for length, width, and height. You can also specify number of units. In this particular case, we're going to have several main blocks between different types of garages, parking, small boxes, and large boxes. A small box could be representative of the multifamily bars. A large box could be representative of the grocery aspect. From this point, these cuboids, as these things are made out of, will have specifications based off length, width, and height, number of units, same thing. But there will be basically tie-ins back to ratios. So, for example, like if there's a height that we can't go over, then the bounding box will not let us develop anything that goes over that height. It'll also not let us input more area on these boxes, on these accumulated boxes, than what's necessary. So essentially from that, we'll get a list of boxes, and then we can start packing them into the space in various different ways. And right now, the algorithm is just a random algorithm. I'm just trying to create a solution that gets options in there. As the rules get defined, then it'll be a different case where the packing won't nearly be as random. But this will start developing the solution boxes. And of course, we can go the generative design route, which we were talking about in Overflow 2, which will kick out various different options. And then, of course, we can pick one to go with the solution box. This is kind of the idea behind the nodes, the logic behind them. Specify site boundary nodes. You can specify specific types of blocks, specify things like site setbacks for the site, what the FAR might be, specifications for the grocery block or residential block. You can adjust the parameters, and we can add as many parameters in there as we need to kind of adjust these blocks or give it any kind of metadata that might be useful for us. The placement of the blocks could be anything from developing attractors, right? So attractors could be something along the lines of like a pedestrian access point. We definitely want to orient to that. Or if there's a main road, we want to orient, let's say, for example, the grocery store towards the main road. Or if there's a green space or some kind of community amenities or something like that, we want to place the multifamily bars in relationship to. This results in translational blocks, which essentially creates rotation, height offsets, and orientation on the site. And then we can also come back with random weighted attractors, where essentially if there are multiple attractors or multiple points of interest to each of these blocks, then we can either randomize the direction that these things rotate or face or offset, or it could be something where it might take a certain percentage of pedestrian access is 70% important, while the sun sun direction is 30%. So we can start putting that kind of math in there. This last one is just an example of one of the basically the interior of the Dynamo nodes themselves. So essentially, this is a code block utilizing Python, but I'm not going to go in depth into this, but this is an example of the level of coding that goes into one of these boxes. Now I'm going to stop this now, and we will move on to the demonstration portion. In here, we will take a look at kind of setting up the initial site in Forma. So let's go ahead and get this started. Let's go to College Park, Florida. Now I have a specific site here that we're going to be utilizing, so let's go ahead and zoom into it. This is a site that has existing multifamily and grocery on it, and we're going to take a look at redeveloping this site for the future project, but for right now, we're going to showcase the process. So we're happy with this. It's going to be this plot and this plot here, potentially this plot as well. So let's go ahead and confirm our map area. This will take a second to create. Okay. So once it's in here, there's various bits of information that we'll have to import that will help with our initial site analysis. As this pulls up, we can start pulling in building data, road data, parcel data, and terrain data, things along those lines. So what we're going to pull in, let's pull in OpenStreetMap. This will give us buildings. That is our area. We'll order that. Okay. We also want to pull in terrain. So let's go ahead and pull in, we'll pull in USGS. USGS, FEMA, and terrain all pull from the same sources. So we'll do that. And it looks like this is already added, so it comes in by default, so we're good there. We also want to pull in the mapping. So for the parcel information, because we're going to need the parcel information. Now, a lot of times, if the site is too large, it won't let you pull in the entire thing. So we'll have to be more specific on the area that we pull in. So we definitely were interested in this site, this site, this site, and we could possibly look at this site too. So this will give us all the parcels within this area. Let's go ahead and order that. Order successful. Great. Now, looks like we have that going great. Let's go ahead and pull in roads while we're at it. Add, and I want to pull this back over here and grab the full amount of the roads. Just for context, because it's going to be important for noise analysis and kind of understanding the pedestrian walkways. All that looks great. Let's go ahead and exit out of that. Here we are. Let's start by pulling in our information. So let's go ahead and load our information. So we want to preview the roads. Roads come in. Let's add that geometry. Property boundaries, pull those in. That looks good. Let's add those. Buildings. Looks good. Let's add those. And the terrain is already loaded in, so we don't have to worry about that. Okay, so here's the two sites we were talking about specifically for this. These are the ones that are going to be exported out. So let's go ahead and create some site elements, the shape and the shape, right? So these are the two sites that we'll be working with, and we can come back and actually name these sites. Site A, Site B. We can come back after the fact and combine these two sites, but we can deal with that a little bit later. Now there's some existing buildings here from the building information that we pulled, and we're not going to be needing those. But in the meantime, we have the site information that we're going to pull from. We can just do some quick analysis just from looking at this. I know the main road's here, the main road's here. We can run very simple analysis to begin with. So right off the bat, we'll get some basic area metrics. We know that this particular site is 193 square feet. There's no buildings on it yet, so there's no information here that we can really work with. Same thing here, we've got a total amount of footage that we're working with. So let's go ahead and look at exporting this out. So the way this works, oh, exit drawing mode. Okay. So sorry about that. So you can do various proposals, proposals 1, proposals 2, and this is what will happen with our iteration. This is where it'll be helpful. But we can do send to Revit. You'll have to have the Revit add-on to make this work. You can also do export, which will export out the proposal. From inside Revit, of course, now you can pull the proposal in one way or the other. So let's go ahead and stop here, and the next step will be inside Revit and Dynamo. Okay, so let's go from Dynamo, well, not Dynamo, Forma to Revit, and then back to Forma. And then Revit will be using Dynamo. So this is the site that we had made earlier. Let's do a quick little something here. Let's just add a basic building real fast. This is just to show the relationship of the geometry. And let's just take it up 20 feet. Oops, sorry. Okay. So we got a generic mass in there, and we can come back and modify and do whatever we need to. So just to make this thing stand out, we're going to say it's 30 feet and it's 2 stories. All right. So that's just a massing block. It doesn't really mean anything right now. So let's go ahead and export this out to Revit. So we were going to go here, Revit, we're going to send a Revit as a link. Proposal has been sent. In this case, we will pull up Revit. So what we're going to do in here is under massing inside, there's the Forma add-in. You had to download and install this earlier. We're going to load the proposal. So you definitely want to check options. Now you can have it based off of the geometry that's in there, create walls, floors, and roofs, and things along those lines. We're not going to have to worry about any of that right now. But what we will have it do is create conceptual masses for 3D sketch elements. So we'll have that in there. Actually, no, we're going to leave it out because we're going to pull in the geometry from Revit. In context, create lines from the site limits, project boundaries, rails, all that, apply terrain. We're not going to need terrain for this, but if there is a terrain heavy site, you could import that information and be able to cut site sections and things like that to kind of understand it. But really, we're just interested in the context of the site right now. So let's go ahead and click OK. And let's load the proposal. Looks good. This part usually just takes a moment. All right, so let's zoom out and see what we actually got. Okay, so it looks like it brought in a lot of the parcel data, brought in our 2 site elements that we're interested in. What we're going to do is the model base, right? That was all the parcels and everything that comes in as a group, and then these guys come in separate. We're going to go ahead and hide this for now because we're not going to need it for what we're doing here. Because really all we need are these two pieces right here. Now, why this is going, it's going to take a second. In the meantime, I had uploaded Dynamo, and I have a custom script sitting in there right now. Essentially, the way the script works is right now it's a random plot generator or random box generator. Basically, so you select a boundary, and then based off of that boundary, it places boxes. Right now, it's random boxes, but you can specify the size of the boxes. So let's focus on this guy first. And let's go to there. And we are going to want Dynamo. Let's go ahead and open up site boundary. Right. That's open. We can come in here. Yes, I just trust it. You'll want to keep this on manual so this thing doesn't automatically run on you all the time. I'm not going to take the time to go through the entirety of this node. There's a lot here, but really all we need to focus on right now is just selecting the model elements. This will be our boundary. Okay, we've got those selected. And I've already got some basic information in there, right? So there is height of the boundary box. I set it at 100 feet. This will be based off of code analysis to determine what the bounding box of this site actually is. And then there's other information that you can put in here relating to essentially the size of the boxes themselves. But I've got a set size in here right now. Let's go ahead and run it. Okay, so it created a box, which is the bounding box of the site. And then it created a whole series of kind of randomized boxes. Now, these boxes are just 20 foot by 70 foot. So basically, these are just regular little retail bays. But this is just to show the kind of creation and just the process of making boxes and things in here. Now, the script in a future iteration will start orienting these boxes and changing their different sizes, right? So there'll be boxes for the grocery, boxes for the multifamily bars, and boxes for garage parking and surface parking, and possibly boxes for community spaces, parking areas, and things like that. And those things will have attractors associated with them. So, for example, if the main road is here, you want that to be kind of a forward-facing thing for maybe the grocery store itself. The grocery store would orient itself in this direction. And then the multifamily might stack on top, or it might locate into the back when this one takes priority. So that's all that's going to be worked into the script. But right now, the idea of the script is just to get boxes in there. So let's go back to Revit. And we can see we've got our boxes in there. Those all came in good. Let's run the other site. Sure, I hide those because I do not want those to accidentally get selected. Great. Let's come back here. Let's come back and select new elements. You have to get all the elements into a closed box and run it. It did not select the elements. Okay. Now it's selected those, got rid of these, and it's going to focus on this site now. Run, and you can see it put them in there. In a future iteration of this, what I'll have is, as it creates these boxes, it'll drop in actual real geometry. So these will convert to something real. Right now, these are just kind of spatial anomalies. But right now, we've got something that we can work with. Let's go ahead and load this back into Forma. Before we load into Forma, let's do a couple of other things. Say, for example, the script gives you a couple of blocks and things that you definitely want to utilize, but let's say there's something that you want to modify or put in there yourself. You can always do in-place masses to add to it. So let's put one here, create form. Mass is turned off by default. We will turn that on. Okay. So we've got a series of masses created by Dynamo. We've got one that we've created by hand. Let's go ahead and drop this back into Forma. So we're going to go massing and site, update proposal. We're going to specify the view we want, which is just this view here, and update. A new Forma mesh will be created from one Revit element. Yes. Okay, great. Now in Forma, to get it to refresh, you have to actually step out and then step back in. So we are going to step out and then step back in. There. And our masses start to come in. So at this point, I can start running analysis on the designs that we've come back with. Basically, I'll have some initial area metrics that'll start to give basic information. I can do sun studies, daylight potential, wind analysis, microclimate studies, noise studies, solar energy usage, carbon footprint, and we have options for additional extensions from various developers that we can add in there as well. So for example, TestFit creates parking. That's an input into here. In the meantime, let's go ahead and run one of these to see what this would look like going through this process. Now, I'm not going to go through and run each of these. I'm just going to do one or two just to kind of show the results that these things produce. While this is running, I will do wind as well. And wind will be, it's got two ways to do it. There's an initial kind of AI-based wind generative study that it will do. And then there's also a detailed analysis that it will run. But this particular one takes roughly an hour, hour and a half to run. It's very in-depth, very thorough. The AI one is the quicker one. But this starts to give us some basic information, and we can look at the comfort levels and wind direction. So I can start specifying essentially where the main winds are coming from, and start kind of using this for my analysis, like what needs to change in the design. Let's go back to our sun hours and see if that analysis finished. Yep. So it's coming back and it's starting to tell me these are kind of the areas that get sun exposure, right? So the darker areas are areas that are usually in shade for most of the day. The lighter areas are the areas that get the most sun exposure all day long. So as you can see with a block like this, it's very, very, very exposed, but you can start to kind of get an idea of kind of shadow zones that start to develop that you could take into account whenever it comes to your sun studies. Anyway, so this is this portion of Forma to Revit back to Forma. We will stop with this one and move on to the next one, which is TestFit. Okay, this is the last part. This is the TestFit portion. And that'll be TestFit to Revit. Now, one thing to keep in mind is right now there is no import of these Dynamo, Revit, Forma geometries into TestFit. So really it becomes a case of having to kind of manually recreate the massing to kind of get this information. And a lot of this is about kind of recreating the content that you've kind of already made, so that there is kind of a massive pitfall that hopefully we can get around it in future iterations. But for now, for this demonstration, we're just going to recreate, go through the steps of recreating a site. So the massing that we've done before has been very generic, right? So I'm going to be very generic with this one as well. This is just kind of talking about the process. So the first thing you have to do is define the parcels. We're going to define this guy today. And inside TestFit, you can do these automatic solvers for different things. So parking, offices, um, retail spaces, retail plazas, parking structures. And then, of course, you can do higher density things. So like um, start getting information for different types of towers. Um, yeah, like Gerbins or infills, all multifamily things. And then, of course, you can go through lower density options, parcel breakouts, office buildings, and et cetera. There's lots of options here, but for our stock, since we're not kind of starting with anything right now, we're just going to leave it as blank because we're going to have to build this. So we're going to go ahead and solve, and it's just going to be a blank mass. So from here, what we're going to do is just create a series of masses. And the idea is that these masses would be based off of what we had created earlier. But since that was randomly generated, we're just going to make a couple of interesting ones here. So there's a bunch of ways to approach this. Right now, all we're going to do is just create a series of masses. This first mass will be a retail base, kind of a grocery mass. We're going to draw an outline. Okay, so we'll have some type of inside TestFit is called retail, but we're going to be classifying it as grocery for our use here. So that's that part. Let's add some parking to this. So while we're doing this, let's go to 3D so we can kind of really start visualizing this. Let's go to the retail. Let's duplicate above. And let's change this retail to parking with detail. So we've got some parking with detail. Let's add a couple of multifamily bars. So we will create another space. And these are just going to be the bars. So we'll do something like this. And of course, you can turn on snaps. And we will change you to multifamily. Now, the way this thing works is it's based off of a hierarchy system. So the higher up an object is, it'll overtake the objects below it. So for example, if I was to move this down, you can see that the grocery store would start to take over. So to kind of see this, what this looks like here, multifamily being on the bottom, we will add a couple of levels. So we can see that the grocery store and the parking garage take precedent up to level 2, and then from level 3 on, the multifamily starts to kind of build out. So that's kind of how that will work. From here, we can run a solver on the multifamily. Now, one of the problems with this particular solver, the way it works now, is everything is very vertical based. So if I have, in this particular case, this overlay, it's not going to account for that little notch that has been taken out. So what I'd have to do is move multifamily up to here and have it carve out of the parking and grocery, and then come back in and kind of manually void that information out. But just for this example, we're not going to go through those steps. We're just going to show the solver in action. Infill unparked. Okay, so it creates a multifamily structure. Since we're playing around with this, let's just move this up to kind of show it kind of intersecting and tying into there. Yeah, that'll work. Let's go ahead and go to 2D and see what the floor plan looks like. So we get a couple of floor plans, basic units. We can see the relationship of that with the, it's called retail, but it's really the grocery store in here, and then its relationship with the parking. So from here, even though there's no import function from these other geometries right now, we can export this content out to Revit. What it does is it's not Revit native, it is SketchUp and DXF. So for our particular case, we are going to export out a SketchUp file. So we will go File, Export. do a SketchUp model. This is the demo. Save. Yes. That'll take a second to go. All right. So that's a relatively small file. Would have went out. So let's come back here. So these are our generated Dynamo in kind of Revit. So this is kind of the combination of Forma elements, Dynamo and Revit elements, and now we're going to bring in the TestFit elements. And let's go ahead and bring that in. Insert, link CAD, College Park demo, open. Now, one thing to keep in mind, this is actually kind of a bothersome thing, is it doesn't always pop up in the same coordinate system. The coordinate system always seems to be a little bit off, so you will have to manually kind of put it back into its spot. But this is a case of going from Forma to Revit, Revit creating Dynamo, Revit also creating masses, trying to recreate some of that content in TestFit and then re-importing it back into Revit. The idea being Revit is the kind of common ground where all these languages kind of come together and speak. So now that we've got this and all these elements kind of pulled and tied in together, let's push this back out to Forma and see what the final results are. Actually, just so this looks halfway like something, because this is a big box, it kind of covers everything up. I'm going to move this over here like that. And move you over here. You over here. Okay. And let's go ahead and go back to masking and site. Update proposal. Update. Takes a second to go. It's been successfully updated. Cancel. I will come back and save that later. And let's go back to Forma. And we have to refresh it. So basically stepping out and stepping back in. Take a second to update. This is the fun part about a demonstration. It does not look like it brought over the SketchUp elements. So that is something for kind of future study to try and figure out what exactly happened there. But I'm going to go ahead and end this video now. This is basically just a showcasing of the workflow. There's refinement that needs to happen as this is randomly generated. The rules that have been kind of studied and developed and analyzed are going to be incorporated back into the script and in next iterations. These won't be so randomly generated as more intentful and purposeful. Thank you for your time. And this is the live demo. Okay, I do want to make one additional note. Earlier, whenever I tested this, the TestFit file to Revit didn't come in a Forma, and there's a reason behind that. So essentially, whenever you imported it as a link, manage links, it came in as SketchUp elements, and SketchUp elements were not compatible with going back into TestFit from Revit. What you had to actually do was create a 3D massing family. And inside the 3D massing family, what you did was import and link inside the SketchUp file, at which point this gets loaded back into the Revit site family, which is this character right here. For this particular case, I'll delete him and move this guy down into that position. But now this will now go over. So let's go ahead and, as the test, update the proposal. Update. Yes. Okay. And now we will go back to Forma. We will back up. Go back in for the refresh. And it should appear right here. Yep, there it is. So now that that's here, we can start running our analysis on kind of this new design that's been kind of refined with some of the interior pieces as well. So that is the process. I will go ahead and end it here. Thank you for your time with this demo.